Good morning all. We'll try to work out a few numerical problems based on the group capacity of piles. A group of 9 piles, 12 meter long and 250 millimeter diameter, is to be arranged in a square form in clay of average UCS 60 kilopascal. You're asked to work out the center to center spacing for a group efficiency factor of 1, neglecting the bearing at the pile tip and taking the adhesion factor as 0.9. So it's quite simple question based on group efficiency. You have 9 piles in 3 by 3 pattern, and each pile is 12 meter long and 25 centimeter diameter. It is installed in clay whose cohesion is indirectly given. 60 kilopascal is a UCS, so you take the half and what you get is cohesion 30 kilopascal. So if these 9 piles are installed in such a way that you have to have a group efficiency of 1, you're asked to arrive at the spacing required so that this condition is met. Now, of course, you have the 9 piles arranged like this, and it's skin friction because you're asked to neglect the end bearing at the pile tip. So you're assuming that the pile does not rest on a hard strata. Instead, it's completely frictional or adhesional in this case. Anyways, since the UCS is given as 60 kilopascal, you get the cohesion as 30 kilopascal. So case number 1, you assume mobilization of individual capacity, which means each pile act individually. So Q group in such case is equal to N, which is 9 here, multiplied by the capacity taken by a single pile. So individual capacity means that the capacity in the group is equal to number of piles multiplied by the individual capacity. So N is equal to 9 here, and to get QU we know alpha C into AS is a equation because you're asked to neglect the end bearing. So what remains is just the adhesion factor multiplied by cohesion multiplied by the circumferential area. So that's 0.9 multiplied by 30 multiplied by pi dl. D is given, L is given, alpha is given, C we got as 60 by 2. So in short, QG is equal to 9, which is N, multiplied by alpha C AS. So working out gives you a value of 2290 kilonewton approximately, which means when each of these piles act individually, you will get a total capacity of around 2290 kilonewton. Now, case number 2, when you have group capacity, which means the entire block act as a single unit. So each pile do not act individually. Instead, the entire group try to settle as a single rigid unit. So the perimeter of the entire block needs to be considered. QG is equal to alpha C into perimeter into depth. So alpha C, we know alpha is given, we know C, perimeter you can find out from the basic geometry, where S, the spacing, is unknown. D is the depth, which is already known. It's given in the question as 12 meter. PG, perimeter, is equal to 4 times 0.125 plus 2S plus 0.125. S being the center to center spacing. So when you take one side of this block from left to right, that is 0.125, which is half the diameter, plus S plus 0.125. So in short, it's 0.125 plus 2S plus 0.125. So that's one side and is in a square pattern, so multiplied by 4, what you get is a perimeter. So QG is alpha CPG into D, where D is already given 12 meter, PG you know from this equation where S is the unknown that we are about to find out, C is a cohesion 30 kilopascal, alpha given in the question is 0.9, but think about alpha. Alpha is the adhesion factor which is realized when the interaction is from soil to pile. But in this case, what really happens is that the entire block is moving as a one single unit. So the interaction is at this boundary, which is soil to soil, soil to soil, soil to soil. Had it been one single pile in individual capacity action, the interaction will be from the concrete to the soil. But in this case, in the group case, alpha is not equal to 0.1. Instead, it's soil to soil interaction, or alpha is equal to 1, which I have highlighted in red font. So you have an equation for QG where S is unknown, and you have an equation for QG where the value is known. So to have the unknown spacing, in the question it's given efficiency as 1, which means eta is equal to 1, which means 100% efficiency. So what you can do is you can equate these two to get the spacing, which is unknown, 0.67. So in short, when 9 piles 12 meter long and 25 centimeter diameter are kept at a spacing of 0.67 in a clay of 60 kilopascal UCS, you can have an efficiency of 1 or 100%. That is the essence of the story. Moving on to the next question. 200 millimeter diameter, 8 meter long piles are used as foundations for a column in a uniform deposit of median clay of QU 100 kilopascal. The spacing between the piles is 500 millimeters. There are 9 piles in the ground arranged in a square pattern. Calculate the ultimate pile load capacity of the group considering end bearing and assuming adhesion factor of 0.9. So the data given in the question, UCS is 100. So you can have C is equal to 50 kilopascal, right? Half of the UCS. And the geometry given in the question is like this: 9 piles, 3 by 3. Spacing is already given. Unlike the previous question, it's given as 0.5 meter or 500 millimeters. And the diameter is already given 200 millimeters. The length of the pile is already given 8 meters. So just like in the previous question, we'll start with the individual capacity. Individual capacity QG is equal to N into QU, where N is equal to 9. QU is not just alpha CAS, it is CNCAP plus alpha CAS, because in this particular question you are asked to consider the end bearing. So QU is equal to CNCAP plus alpha CAS. So the first term takes care of the end bearing, second term takes care of the skin friction. So the CNC term is nothing but the first term that comes into picture when you're considering the Chassagas equation. Like we said, the other two terms, half gamma B and gamma, and the second term gets neglected in case of a pile foundation. That's a usual practice. And NC in case of pile deep foundation is 9, usually taken as 9. So as graduate students, you have to keep this value in mind. NC is equal to 9 for piles installed in the soil of clay nature, for deep foundations, of course. Anyways, so C, the value is already given 50 kilonewton per meter square. NC, we take it as 9. AP is nothing but the end area, pi into d square by 4. Alpha is already given 0.9. C is already given 50. AS is nothing but the circumferential area, that's pi into d into L. So working out, you get a value of around 240.33 kilonewton. That's the individual capacity mobilized by a single pile. So to get the group pile, you multiply it by n, or number of piles. N is equal to 9. So 9 multiplied by 240 is equal to 2163 kilonewton is a load that the entire group can take if each of these piles act individually. Now, when they act as a group or a block, you need to consider the perimeter, just like in the previous question. So they act as a block. So QG is equal to CNC into the area of the block at the end bearing plus alpha C in the area of the block around the circumference. So QG is equal to 50 into 9 into 1.2 into 1.2 plus alpha C into 1.2 multiplied by 4 into 8. So I'll discuss what each terms are. You may have figured it by now, but nonetheless, 50 is a C cohesion value, 9 is the NC value, area of the block 1.2 multiplied by 1.2 is nothing but the plan area of this rigid block. So spacing is already given 0.5, diameter is already given 0.2, so you know the radius. So 0.1 plus 0.5 plus 0.5 plus 0.1 is the length of one side, so that's 1.2. So 1.2 multiplied by 1.2 is the area of the rigid block in plan, so that is a block. Alpha, since it's soil to soil interaction, I have taken it as 1. C is already given in the question. AS block, I'm sorry, I missed an S here. It's AS block, which means the circumferential area of the block, that is perimeter 1.2 into 4 multiplied by depth 8 meters. Solving this equation, you get the group capacity in group action as 2568 kilonewton. So in the previous slide we got one value as 2163, and in this case you get 2568. So from an engineer's perspective, it's always good to have the lower value, which is from the individual capacity, to be considered on the safer side. So finally, the answer to this particular question is a lower value, which is 2163 kilonewtons. Again, try to work out these problems on your own and just try to see if you're getting an answer similar to the one that is shown in the slide. Now, a couple of problems for you to work out as assignment. Number 1, you have a concrete pile, 45 centimeter diameter, installed into a layered cohesive soil. 16 meters is the length of the pile. Water table is close to the ground level. You're asked to find the ultimate capacity, taking NC as 9. So you have 3 layers. Thicknesses of each layer are given. Cohesion of each layer are given. Adhesion factors are given as well. So you're asked to find the ultimate capacity. Now, this question is quite similar to what we have done in case of a 3-layered system and cohesion-less soil. Now, this one is a bit simpler because it's clayey soil. You don't have to find sigma, V, etc. Every terms that would help you to solve the problem are already given in the question. So try to work out this on your own and submit as an assignment. Next question for assignment. You have a reinforced concrete pile weighing 30 kilonewton. It's driven by a drop hammer weighing 40 kilonewton, 4 tons, having an effective fall of 0.8 meters. The average set per blow is 1.4 centimeter. The total elastic compression is 1.8 centimeter. Assuming the coefficient of restitution is 0.25 and a factor of safety of 2, determine the ultimate capacity and the allowable load on the pile. So this particular question is based on the dynamic formula. So try to solve these 2 questions and submit as an assignment in Google Classroom.